Hey everyone, this is the Math Nexus, and today we are going to start with exercise 3.7. This is going to be our practice exercise. There's no new concept, just past papers. It's really easy, but a bit conceptual. I would say it's a bit harder than the specific exercise we've been doing till now. But let's continue and see how it goes. So we'll jump straight in because there's no new concept, to be honest. So for question number one, we have a simple solve 2 raised to the power x squared minus 5x is equals to 1 over 64. So we have done the concept of indices and surds, and we do know that in order to solve this type of question, we have to uh, try to make the 64 into a base of 2. Okay, so we have to try to make the other side a base of 2 also. As you may know, if we take the LCM of 64, 64 to 16, and we have 2 8s, 2 4s, 2 2s, and 2. Okay, so we have 2 1 2 3 4 5 6. We have 2 raised to the power 6 is equals to 64. So we can, as you know, we can write this as x squared minus 5x equals to 1 over 2 raised to the power 6. I hope that is correct. Yeah. Now, the other thing you do, that's one of the rules we have learned, that if you want to take this denominator into the numerator, we write this as 2 raised to the power negative 6. That means we change the power sign into negative. So we are going to get, as you know, these bases are now same. We can equate the powers. We get x squared minus 5x is equals to negative 6. Now you can solve this up. X squared minus 5x plus 6 equals 0. Now if I were to solve this, I would get the factors of 6, which are 3 and 2. So x squared minus 3x minus 2x plus 6 equals 0. X has the common x minus 3 here, minus 2 has the common x minus 3 here, equals 0. We have got x minus 2 multiplied by x minus 3 equals 0. And that means x equals to positive 2 and positive 3. That is it for question number one. Pretty simple. Question number two is 4 raised to the power x divided by 256 raised to the power y equals 1024. And 3 raised to the power 2x multiplied by 9 raised to the power y is equals to 243. Now, as you can see, it's going to be really hard solving it just like that. So we are going to simplify this equation. Now, first simplify equation number 1. Sorry, this is 2. Simplifying equation 1, we would get, now one thing common in all of these is that all of them can be taken into a base of power 2. So if I were to take the LCM of 1024 and what do you say, 256. So first of all, take out the LCM of 1024. If I was a 10, 2, 1, 2, 2, 2, 4, 12, 2, 1, and we have, wait a second. 4 is a 8, and 2 2 is a 4, and 2 1 is a 2. So as you can see, it's a pretty long list. 1, 2, 3, 4, 5, 6, 2, 3, 4, 6, 7, 8, 9, 10. 2 raised to the power 10 is equals to 1024. Okay, so if I were to simplify this, what is 4x? Well, we can write this as 2 squared x divided by 256 would be 2 raised to the power 10, and we multiply that with y equals to, what is 1024? So sorry, 256, my bad. So 2 raised to power what? Well, we can see around here that 2 raised to power 8 is equal to 256. So 2 raised to power 8y equals to 2 raised to power 10. Now, if we were to simplify this even further, we would get 2 raised to power 2x, and as the bases are same, we can subtract the denominator's power from the numerator is equals to 2 raised to power 10. And now we can simplify this to get 2x minus 8y is equals to 10. So this is our new equation number 1, we'll call that. Now simplifying equation number 2. Now what you have to do, now what you're going to do is you're going to write this down. 3 raised to power 2x, well, that's the simplest form we can write that in. Multiplied by what can 9 raised to power written as in the simplest form? It's going to be 3 raised to power 2y equals to 243. Now again, divide, take out the LCM for 240. So if you were to take the LCM out for 243, so the ones 3. Okay, second we can just directly write this as 9, which is 3 squared. In fact, just write it. So 3, 2, and then we have 3 times 3 1 6. Okay, so we have 1 2 3 4 5. 3 raised to power 5 is equals to 243. Now simplify this, we get 3 raised to power 2x, and as it's multiplying, we add the powers. 2x plus 2y equals 3 raised to power 5. If we were to simplify, we get our new equation, which is 2x plus 2y equals to 5. This is the new equation number 2. Now with these two equations, let me first simplify equation 1 more. 2x equals to 10 plus 8y, and that x is equals to 10 plus 8y divided by 2. Simplify this, we are going to get 2 ones are 2, 5s are 10, 2 4 is 8, and we'll get x is equals to 5 plus 4y. Now put this into the other equation, we get 2 multiplied by 5 plus 4y plus 2y equals to 5. 10 plus 4 to the 8y plus 2y is equals to 5. 10y is equals to 5 minus 10, which is negative 5, and y is equals to negative 5 over 10, and that is going to be negative 1 over 2. Same for the value of x, 5 plus 4 multiplied by negative 1 over 2. 2 ones are 2, 2s are 4, and we've got 5 plus, in fact 5 minus 2, which is x equals to 3. So these are the two values for this part, x equals to 3 and y is equals to negative 1 over 2, or you could say 1.5. I hope that is clear. This is it for question number 2. Proceeding on to question number 3. Let me just. Okay, for question number 3, we have 36 raised to the power 2y minus 5 divided by 6 raised to the power 3y is equals to 6 raised to the power 2y minus 1 divided by 216 raised to the power y plus 6. Now, as I write this, I already know that the simplest base I could get out of this is 6. So we are going to take in consideration 2 as the simplest base term. Now, before we start, let's simplify 216 in terms of 6. 216 in terms of 6. So 216 divided by 6 is 36. So 6, 36 is 216. 6, 6 is 36, and 6 ones are 6. So we have got 6 cube is equal to 216. I hope that's clear. Now simplify all of the equation. We get what is 36 in terms of 6. Yes, we have got 6 raised to power 2, which is 2 multiplied by 2y minus 5 would become 4y minus 10 divided by, in fact, just write it this way because the denominator is going to come into the numerator. So we are going to subtract it. So minus 3y as well equals to 6 is in the simplest form 2y minus 1 divided by the way, 6 raised to the power what is 216 3. So 3y plus what is 6 multiplied by 3? It's equals to what was it? 18. 3y plus 18. So, and if I were to simplify this again further, 4y minus 3y is equals to y minus 10 equals 6 raised to power 2y minus 1 minus, again, it's important for it to be in a bracket, 3y plus 18, and we would get, now as the base would cancel out, we get y minus 10 equals to y minus 1 minus 3y minus 18. So simplify this now. We have got 2y. This y, when this y comes on the other side, we get 2y minus y, which is y. Get this down. In fact, we have got minus 3y also. Before we do that, I'm going to take 2y minus 3y in terms of here. 2y minus 3y is going to give us negative y, and when negative y goes on the other side, it's going to be positive y. So we have got 2y, cancel this down. Negative 1 minus 80, minus 18 is equal to negative 19, and when negative 19 comes on the other side, it becomes positive 19. So negative 10 plus positive 19 equals to 9. So this is going to be plus 9, and the other side is going to give us 0. In fact, what we are going to do is 2y is equals to negative 9, and y is equals to negative 9 over 2. Okay. If I were to simplify this, what is 9 over 2? We all know that's 4.5. So we can write the answer as y is equals to negative 4.5. And that is it for question number 3. As you can see, these are really basic questions. And before I continue further, I'm going to tell you that indices and surds are not, you know, the questions are not explicitly in the syllabus because they have removed that as a chapter. But however, all of these concepts I'm telling you is because they do come in the paper. Because Cambridge has, instead of making a chapter, Cambridge has now announced that it is actually practical basic knowledge. So it's essential. You can't say we don't have a chapter of indices and surds in our AdMath syllabus. You can't say that because you have to encounter those type of questions throughout the exams. Okay, for question number 4, we have integers a and b are such that a plus 3 under root 5 whole squared plus a minus b under root 5 equals to 51. Find the possible values of a and the corresponding values of b. What we are going to do is we are going to first of all simplify this up. A plus 3 under root 5 whole squared plus a minus b under root 5 equals to 51. So we have got a squared, simplify this first, plus 2ab, which is 2 multiplied by a multiplied by 3 under root 5, plus b squared, which is going to be 9 multiplied by 5. And what is 9 multiplied by 5? It's 45, plus a minus b under root 5 is equals to 51. Now what I'm going to do is simplify this further. A squared plus 3 to the 6, a under root 5 plus 45 plus a minus b under root 5 equals to 50. Simplify this further, I get a squared. What is plus a here? And then we have got, take under root 5 as the common, 6a minus b, and this 45 goes on the other side to become 51 minus 45. And what's 51 minus 45? It's 6. So we have these values. Now how are we going to solve this? That's where most people get stuck. And the thing is, we all know that we can only get under root 5 when there's, I don't know, how should I explain this? Okay, so wait a second. When we have a squared plus a, we do not have any under root value here. Okay, you're not under root x, you do not have under root 6 or whatever it is. So we do know that this value is probably a whole value. However, on this side, when we have an under root 5, okay, we say that it's a third value because it has under root 5 written to it. So I have two different groups in my answer, with a group of whole numbers and a group of a number which has under root 5 attached to it, which is probably in decimals. So what I'm going to say is a squared plus a equals to 6. And the reason why there's nothing related to under root 5 is basically because this under root 5 has under root 5 multiplied by 0 on the other side. That's why it's not showing up on this side, but it's existent here. Okay. So if I were to simplify this, I would say a squared plus a minus 6 equals to 0. And then I'm in sorry, made one step early. A squared plus a should be equals to 6, and then a squared plus a would minus 6 would be equals to 0. And then by solving this quadratic equation, I could configure my value. Now for the quadratic equation part, there's a really good feature for those of you using the Casio FX991EX ClassWiz. You just simply have to uh, hit menu setup, A, 2 for polynomial and 2 for the degree, and then you can easily solve quadratic equations. So 1 squared plus 1a minus 6 equals to x. So we have two values, x, a is equal to 2 and a is equal to negative 3. Second, to a is equal to 2 and a is equal to negative 3. Now, for these two values of A, we have to find the corresponding values of B also. So when A is equal to 2, I'm going to use my equation. 2 squared is equal to 4 plus 2 plus under root 5 multiplied by 6, 2 is 12 minus B equals to 6. So 4 plus 2 is 6. So this and this cancels down, because when the 4 plus 2 comes on the other side, it subtracts from 6 and becomes 0. So 12 under root 5 minus b under root 5 equals to 0. Simplify this, we get negative b under root 5 is equals to negative 12 under root 5. Now we cancel this down and cancel under root 5 down, because both of are the common on the other side. And when this under root 5 goes on the other side, it basically divides and cuts off. So b is equals to 12. Now for the other part, we have got, for the other part, when a is equal to negative 3, when a is equal to negative 3, what would be the corresponding value of b? We have negative 3 squared is positive 9, obviously, plus, in fact, minus 3 plus under root 5, in fact, plus under root 5 multiplied by 6 multiplied by negative 3 is going to be negative 18 minus b equals to 6. Again, 9 minus 3 is equal to 6, so this and 6 cancels down. Negative 18 under root 5 minus b under root 5 equals to 0. Negative 18 under root 5 is equals to b under root 5. And then b would be negative 18 under root 5 divided by 5 equals to b. Cancels down. Negative 18 is equals to b when a is equals to negative 3. And that's it. This is it for question number 4. Proceeding on to question number 5. Now, these type of questions in which we have without using a calculator, we do not commonly see them in the recent exam, and that's because of the non-usage of calculators in paper 1. So you won't be doing these type of questions. I mean, your question won't have this without using a calculator, because in P1 there's no calculator at all. So basically, before we go forward, let's understand what the question says. It says that we have to express this into a plus b under root 3. So basically what they're telling us that we should simplify this. And how are we going to simplify this? Now, the first thing you see in this, if I were to write this in the correct form, 6 divided by 1 plus under root 3 whole squared. I hope you understand this. I brought this thing on below in the denominator because it has a power of negative. So as we know that we should not have any third or in the denominator, and that's why this is not our favorable equation. So how are we going to simplify this? First of all, we simplify the denominator. So 6 divided by a squared, which is 1, plus 2 multiplied by ab, which is 2 under root 3, plus b squared, which is 3. Simplify this, we get 6 divided by 1 plus 3 is 4, plus 2 under root 3. What I prefer doing is that simplify my equation. So 2 multiplied by 3 is equal to 6 divided by 2 as the common, 2 plus under root 3. So this simplifies to 3 divided by 2 plus under root 3. Now I have to use the conjugate set in order to simplify this. For those of you who do not know the conjugate sets, please watch my previous lecture. They're one of the main concepts in indices and sets. So 2 plus under root 3, what would be the conjugates of 2 plus under root 3? Obviously 2 minus under root 3. So now we can't simply multiply it by 2 minus under root 3 because that would change the original equation. So we have to divide it by 2 minus under root 3. So that essentially means we are multiplying by 1 and we are not changing the value in any sort of way. So we simplify this. 3 multiplied by 2 is 6 and 3 multiplied by under root 3 is under root 3 divided by, again, a plus b multiplied by a minus b is equals to a squared plus minus b squared. So what is a squared? 2 squared is 4 minus b squared is 3. So we have got 6 minus 3 under root 3 divided by 1, and that is equals to 6 minus 3 under root 3, and that's your answer. That's it. This was it for question number 5. No big deal. Really basic concept. We all knew that. Thank you. For question number 6, we have a different type of question. Do not use a calculator again, but they've told us to write this in the form p under root 5 plus q. Again, we can see a problem in this type of equation that it has a conjugate as a surd in it. So we are going to simplify this. 4 under root 5 minus 2 whole squared is equal divided by under root 5 minus 1. So now you have to solve the square on the above side because the type of equation they have given has no square. So we have got to simplify this. A squared is 4 4 is 16 multiplied by 5 plus 2ab, which is 2 multiplied by 2 multiplied by 4 under root 5. In fact, this would be minus 2ab plus b squared, which is 4 divided by under root 5 minus 1. Now simplify this, we get 16 multiplied by 5 is, okay, you do not have to use a calculator, but still I'm your teacher, so I'm going to use my calculator. It's basic multiplication. So basically 16 multiplied by 5 is 80 minus what is 4 multiplied by 4 is 16 under root 5 plus 4 divided by under root 5 minus 1. So we have got 80 plus 4 is 84 minus 16 under root 5 divided by 5 minus 1. Now I'm going to simplify this. How I'm going to simplify this? I'm going to use the conjugate set. So 84 minus 16 under root 5 divided by under root 5 minus 1 multiplied by under root 5 plus 1 divided by under root 5 plus 1. Simplify this. I'm going to use the FOIL method. Okay, for question number 6, by the way, my mic just went down and I didn't know I had done till question number 8. So I'm going to start again from this part. So again, simplify this. 84 under root 5 outer value multiplied by the outer value plus 84 inner value multiplied by the inner value minus 16 multiplied by 5 and the last value multiplied by the last value, which is minus 16 under root 5 divided by a squared minus b squared because 5 minus 1. So if I were to simplify this, 84 minus 16, what is 84 minus 16? We have 68. So 68 under root 5. What is 84? What is 16 multiplied by 5? It's 80. So 84 minus 80 is equals to positive 4 divided by 4. Yes, this can also be further simplified. So 4 ones are 4. For 17 is 68. And 4 ones is 4 again. So 17 under root 5 plus 1 is your final answer for this part. Let me just erase this up so that I can continue with question number 7. Okay, question number 7, part A, part 1. They have told us to show that 3 under root 5 minus 2 under root 2 is a square root of 53 minus 12 under root 10. Now, one basic thing is that simply we know that they've already told us we have to show that this is a square root. So how can we show? We just simply square this, and if the answer of 3 under root 5 minus 2 under root 2 whole squared is equal to 53 minus 12 under root 10, we have proved that this is a square root of that value. So 3 under root 5 minus 2 under root 2 whole square should be equal to 53 and minus 12 under root 10 in order to prove that. So we are going to say a squared, which is 3 is 9 multiplied by 5 minus 2 multiplied by a, which is 3 under root 5 multiplied by b, which is 2 under root 2 plus b squared, which is 4 multiplied by 2. Now simplify this. 9 5 is 45. What is 45 plus 8? By the way, let's do this afterwards. Minus 2, 3 is 6, 6 to the 12. The 12 under root 10 equals to what? Okay, so 12 under root 10. Now let's simplify this. 45 plus 8 is equals to 53 minus 12 under root 10. So we can say that this is hence proved that this is a square root of 53 minus 12 under root 10, because upon squaring that value, we do get 53 minus 12 under root 10. For part 2, they have told us state the other square root of 53 minus 12 under root 10. Now, this may look confusing, but it isn't, to be honest. Now, you all know that whenever we take something out of an under root, for example, under root 9, we have two possible values for under root 9, which are positive or negative 3. So we have that term of positive and negative. And why is that? Because negative 3 multiplied by negative 3 is going to give us positive 9. And 3 multiplied by 3 is also going to give us positive 9. So we do not know which value, negative or positive, comes up. So they've told us this is a square root, and when we take something out of a square root, we use the positive or negative. So the first value is obviously going to be a positive, and if we just simply multiply the other value by negative, we are going to get the positive root of that. So we are going to say 2 under root 2 minus 3 under root 5 is the positive, or you can say other square root of 53 minus 12 under root 10. I hope that is clear. For part B, what they've told us is 6 minus 6 under root 3 plus 7 under root 2 divided by 4 under root 3 plus 5 under root should be written in this form. Now again, how can you simplify this? Just simply write down 6 under root 3 plus 7 under root 2 divided by 4 under root 3 plus 5 under root 2. Now again, we simplify the denominator by using the conjugate surds. 4 under root 3 minus 5 under root 2 divided by 4 under root 3 minus 5 under root 2. Now again, use the FOIL method here. So first value multiplied by first value is 24 under root. In fact, 24 multiplied by 3. Outer value multiplied by the outer value of 6 5 is 30. So we have got 30 under root 6. Inner value multiplied by inner value is 28. 28 under root 6. Last value multiplied by last value 7 5 is 35. So negative 35 multiplied by 2 divided by, or a plus b multiplied by a minus b is obviously going to be equals to what? A squared minus b squared. So 4 4 is 16 multiplied by 3 minus 5 multiplied as 25 multiplied by 2. Okay, so if I were to simplify this, I would get, what is 24 multiplied by 3? It's 72. And 72 minus 35 multiplied by 2 is 70. We all know that. So 72 minus 70 is positive 2 minus negative 30 under root 6 plus 28 under root 6 is going to give us negative 2 under root 6. Divided by, simplify the denominator, 16 multiplied by 3 is equals to 48. 48 minus 50 is negative 2. Now we can simplify this. How do we remove the negative sign from the denominator? By multiplying the numerator by negative. So we have got to multiply this by negative. So we have got positive 2 under root 6 minus 2 divided by 2. And we can simplify this. And we get under root 6 minus 1 is our answer for question number 7. I hope that explains it. Question number 8, we have something, a triangle. You've told us the diagram shows a triangle ABC which angle A is equal to 90. That means that it has 190-degree, which tells us that B to C is an hypotenuse, is a hypotenuse. Okay, sides A and B and AC are stated in the diagram and in the question also. We have to find tan B. Now we all know tan B is equals to opposite upon adjacent. Okay, that's the formula. So what would be the opposite of tan B? So if this is B, this would be the opposite and this would be the adjacent. So this would be the adjacent. Okay, so I'm going to simply solve this up by saying tan B equals to opposite is under root 5 minus 1 divided by adjacent, which is under root 5 minus 2. Now again, we could write it in this form, but it's not acceptable for an under root to be in the denominator. So we multiply it by the conjugate side. So under root 5 plus 2 divided by under root 5 plus 2. So we have got first value multiplied by the first value is 5. Outer value multiplied by the outer value is plus 2 under root 5. Inner value multiplied by the inner value minus under root 5. And the last value multiplied by the last value is negative 2. Divided by what is under root 5 squared? It's 5 minus 4. Now simplify this. 5 minus 2 is 3 plus under root 5 and 5 minus 4 is 1. So that is our answer. 3 plus under root 5 is your answer for question number 2. Oh, by the way, I'm sorry. Sorry. My bad. This is not negative 2. Why is that? Because 5 under root 5 minus 1. This is under root 5 plus 1. Oh, I got it now. There's a problem in the question. So basically, in the question, sides AB and AC are given under root 5 minus 2 and under root 5 plus 1. However, in the diagram, this under root 5 minus 2 and under root 5 minus 1 both have a subtraction side. But however, in this one, this is under root 5 plus 1. So the answer is also going to be different depending on what you copied down. So I've copied down the question part. In fact, I've copied down none. Yes, I've copied down the question part, my bad. So yeah, I've copied down the diagram part. So I've copied down the diagram. According to that, my answer is coming 5 minus 2, which is 3 plus under root 5. And that may be correct. I mean, whatever you think, if you have copied down the other part, I mean the question part, then you're going to get 7 plus under root 5. So whatever your answer will be, you will have a leniency on that, because this is a misprinted question. Question number 9. What does that tell us? Let me just check that out. Given that this is equal to this is find the value of A, B, and C. Now this is a really easy question. There's no big deal in this one, and I'm going to tell you why. Well, we have got question number 9, and they have told us p raised to power negative 2 cube r raised to power negative 1 over 2 divided by p raised to power 1 over 3 q raised to power 2 r raised to power negative 3 inside and under root is equals to PA, QB, and RC. So basically, you have to simplify this equation, and whatever we get out of this is going to be our answer. I mean, the powers of P, Q, and R is going to be our answer. And it's, to be honest, it's not really hard of a question. I need some working, so I'm going to do it from here. So I'm going to write the numerator first of all as it is. R is to power negative 1 over 2 divided by now p raised to power 1 over 3. In order to remove the under root, I just multiply each value by 1 over 2, because that's what an under root represents. By the way, before we go further, let me clarify that if this would be p plus q plus r raised to power negative 3 inside under root, that's not how we would solve it. However, they're multiplying right now, so we can write it in that way. So q raised to power 2 multiplied by 1 over 2, and r raised to power negative 3 multiplied by 1 over 2. And that's how we are going to just remove the under root from the denominator. So p raised to power negative 2, q raised to power 1, obviously negative, r raised to power negative 1 over 2 divided by, now simplify this value, p 1 over 3 multiplied by 1 over 2 is 1 over 6, q 2 multiplied by 1 over 2 is 1, and r negative 3 multiplied by 1 over 2 is negative 3 over 2. Simplify this, we get p raised to power negative 2 minus 1 over 6, q, because the denominator comes into the numerator to subtract, q raised to power 1 minus 1, so this would be this would be 0, and r raised to power negative 1 over 2 minus, inside a bracket you're going to write negative 3 over 2, that would make negative 1 over 2 plus 3 over 2. Now simplify this, p raised to power negative 2 minus 1 over 6 is going to give us negative 13 over 6. Okay, q raised to power 0 and r raised to power negative 1 over 2 plus 3 over 2, and that's 1. So we have got a is equal to negative 13 over 6, b is equal to 0, and c is equal to 1. And that's your answer for question number 9. Yeah, I think for question number 10, I need some space. I'm going to raise this up. Okay. For question number 10, they have told us the diagram shows two parallelograms that are similar. The base and height are in centimeters of each parallelogram is shown. Given that x is the height of this smaller parallelogram, is p, given that x, the height of it is p plus q under root 3 divided by 6, find the value of each of the integers p and q. Okay, so basically this is a question of similarities. So what I'm going to do is simply just do what we do in similarities. So in similarities, basically we know that the ratios are same. So if I'm going to say that this square is the double of this square, we're going to say that the ratio for this is 1:2. And whatever I do, I say this, the height of this is x, so the height of the other square would be 2x. So when we have ratios, the ratio stays constant. So we can just simply use the ratio to find out the values of p and q, which are the integers here. Okay. So what I'm going to say, I'm going to compare the height. So 1 plus 3 under root 3 divided by 6 plus 2 under root 3. This is the base and the height, which gives us the values for the ratios. For the other side, I'm going to write the corresponding side, which is of 1 plus 3 under root 3 of the similar triangle, parallelogram, because I've told you can't, by the way, you can't use this for every single parallelogram, only for those that are similar. And I'm not explaining this concept in detail because, first of all, this is a mathematical, these labels D concepts, so you should know this in terms of mathematics. If you do not know, there's a lot of videos on YouTube, and it's really easy, to be honest, nothing special. Otherwise, I would have explained it. So x divided by 5 minus under root 3. So basically, I set up a ratio for both of these two. Now I'm going to simplify to find out the value of x. So 1 plus 3 under root 3 divided by 6 plus 2 under root 3 multiplied by 5 minus under root 3. So that if I were to multiply this, I would get first value multiplied by the first value 5 plus outer value multiplied by the outer value minus under root 3. So minus under root 3. Inner value multiplied by inner value 5 3 is 15 under root 3, and the last value multiplied by the last value, which, so this would be 3 multiplied by 3 divided by 6 plus 2 under root 3. So if I were to simplify this, first make a partition, I would simplify this to negative 5 minus 9 is negative 4, and the other value would be plus 14 under root 3 divided by 6 plus 2 under root 3. Now again we have to rationalize the denominator, and for that we are going to use our conjugate search. So 6 minus 2 under root 3 divided by 6 minus 2 under root 3, first value multiplied by first value negative 24, outer multiplied by outer value plus 4 to the 8 under root 3, inner value multiplied by inner value is going to be 14 multiplied by 6 is 84 under root 3, and the last value multiplied by the last value is 84. And 84 because 14 multiplied by 2 multiplied by 3. That is going to be, wait a second, 14 multiplied by 2 multiplied by 3. That is going to be 84. Divided by 6 plus 2 under root 3 multiplied by 6 minus 2 under root 3. Again, a squared plus minus b squared is going to give us the answer 36 minus, what is b squared? It's going to be 2 squared is 4 multiplied by 3, which is 12. Simplify this, we get negative 108 plus 84 plus 8 is going to give us 92 under root 3 divided by 36 minus 12, which is 24. Now what can we take the common out? We can take 4 as the common. 4 6 are 24, 4 20 negative 27 is negative 108, and 4 23 is 92. So we have got negative 27 plus 23 under root 3 divided by 6 is equals to p plus q under root 3. So they have given us the form, and now they have told us to find the integers p and q. So p is the whole number inside that. So negative 27 is equals to p, and q is the coefficient of under root 3. So 23 is equals to q. And that's it, and this is it for exercise 3.7, which are the exam style questions. I hope you understand all of this well. If there are any queries or any thing that is unclear, you can feel free to ask in the comments, and I'll try my best to tell you about that. Thank you.